This is DynamoDB Part 2. Let's discuss the partitions and performance, partitions best practices, consistency models, transactions, scan versus query, indexes, the local secondary index, LSI, and GSI, global secondary index. So basically about partitions and performance, the most obvious thing and the most important thing is not to have hot partitions. So partitions key should be eventually distributed among partitions. If we access frequently a specific partition, for this could be because we access a specific key, doesn't mean that we are not distributed. This can mean this partition is hot because we are accessing a specific key. Then we are going to have a hot partition, and this can cause performance issues if we reach the limits of our RCU, which is the read capacity units, or their RCU global, and we should take it into consideration. Basically, the partition's best practice is to use a high cardinality attributes like item ID. You see it's distributed very well, card ID, session ID, things that distribute very well so that we won't have hot partition. It will be distributed, will get good performance. Or we can use composite attributes, meaning we use some ID, it's a combination of IDs or combinations of denominators to this primary key, which would also could make it distributed. The more distributed, the more higher cardinality, the better. We could also use cache in order to avoid actual calls to the low level. So we have the DAX, the DynamoDB accelerator for reads. Using random numbers is also a good way to make partitions key, high cardinality. Hopefully, for all these, we would either have a composite attribute, something that would make sense to us, to humans, that would also have high cardinality, or just high cardinality attributes. DynamoDB has both consistency models. It supports both eventual, this is the default consistency models, and also the strongly consistent models. By default, everything is eventually consistent to support high availability, high performance, with a lower assurance of what we actually get on this latest call. Eventual means do a call, do a read to the database, but beware that what you will get in response might not be latest eventual, right? Might not be latest, overridden by other rates, stale, but if you keep repeating calling this get, then eventually you will get the latest value. Strongly means if you do a call, you will get the latest value. But if I cannot give you the latest value, then I will not give you the previous value. I will return error 500. This means we could have higher latency, and it's not supported on global GSI. We'll talk about them. It requires more RCU because we can do a repeat internally. And where do we specify if we want eventual consistent or strongly consistent? We specify it in the API. So if we do get item, we pass a parameter that we want a strongly consistent read. Now, about transactions. DynamoDB supports transactions. Basically, transaction means an operation of all of nothing. The operation of all of nothing would be both for, you can combine read, write, delete, whatever, multiple writes, multiple reads, all in the same transaction. It would support all the properties of standard transactions: ACID, atomicity, consistency, isolation, and durability. So we bulk multiple items in the same transaction. We can check also for prerequisite. We can say check this condition, and only if it's true, then actually run the whole transaction. Okay, so we group here put, update, and okay, we group here everything, and we group them in this transaction. The transaction will either fail or succeed. We have transact write items so that the whole write would either succeed or fail. Transact get items operation. The cost is basically we have no additional cost to enable this, just to enable this, but taking into account that when we do transaction, we could have multiple reads or multiple, because it's using under the hoods the two-phase commit. Two-phase commits means that we have always two underlying reads or writes for every time we have one. Why? One is in the two-phase commit prepare, and the second is the actual commit, and we would see those in the actual CloudWatch if we look at it. Now for scan versus query, scan is yes, a full scan, avoid using it, can cause a lot of RCU. If we want only some of the attributes to be returned in the scan, we are using the projection expression in the API to tell which columns, which attributes we want to project. We can do a parallel scan if we want higher performance, and we can set also the consistency read on the scan to set it to a strong consistency. In query, it's based on the primary key. We do a get on primary key. It's like not a full-blown query. The primary key could be, for example, a user ID, and we can use optional sort keys to both filter the items, and they would also the results would always be sorted by the sort key. We can use in the query the scan index forward in order to reverse the results, and we can make them more efficient. The query in general is more efficient. The scan, of course, always try to use query, almost never scan. Now for indexes, so we have two kinds of indexes. We have the LSI, we have the GSI. Basically, the GSI is like a new table. We define both a different partition key and also a different sort key. In the LSI, we only define a new sort key. So we have already the partition key, and now we can append up to 5 sort keys. So this is the local secondary index. New sort keys, but we can have only up to 5 new sort keys. We can create them only on table creation time. We cannot remove or modify the LSI. So it's just a new sort key. Same table, same partition key, just a new sort key. It's like a new view on the data. For example, we can have birthday user ID as a combination of the primary key, which is the partition key, as the sort key. And now we're going to have user ID and height. And the height here would be the combination with the same partition key, only a new sort key to provide us with the new sort key. And this is the local secondary index. And for the last item in this episode, the GSI, the global secondary index. So GSI is like defining a new table, because we need indexes, but we already have a partition key. We already split the data. Okay, so let's define something like a new table, which is the GSI, the global secondary index. So it has both different partition key and also different sort key. We can create it at any time because it's not attached to the current table. It's like a new table. It would have different partition key than the original table, different sort key. So we could have here user ID and birthday, and we could have email ID and login time. Two different partition key and sort keys, two different primary keys. We can specify which attributes like the LSI to project to the new tables. We can define for this GSI, because it's like a new table, the new RCW and new WCW, the read and write capacities for this GSI. And this can affect the GSI. We can treat the GSI, the global secondary index, as a secondary table. And it can affect the performance and throttle the main table, even if we have enough WCU, because maybe it's doing some kind of cloning or replication under the hoods, and we need to reflect this. So the GSI can affect the performance of the main table, even if we have WCUs. The LSI that we discussed in the previous sections is not throttling the main table. So basically, I think from this, the bottom line is that we want to use high cardinality attributes. Okay, could be composite, Rule number 1, high cardinality attributes. We generally, if we use DynamoDB, we want to use eventual consistency, strongly consistent. Let's keep it for other databases. It's possible. We can do transactions. I would not do them. I would keep it simple for DynamoDB for a key value store. We can do scan. I would not do it. I would only do a query, keep the scan only for manual operation, one-time check, not for regular operations. We can have different indexes. And here I would claim it's best to try to avoid, to keep it simple, to keep it a simple key value store. It's possible, but see, it's possible only on table creation time, okay? And GSI can cause latencies on the main table. So it's possible, but the more we add complexity to DynamoDB, to the key value store, the more we get to a relational database. So it's a trade-off. Try to keep it simple. It's a key value store. If you need a different database with all this complexity, just use a relational one. It will do the job. So this was a brief introduction to additional items on DynamoDB.